Okay, we'll move on to our Unconference section now, and I believe we've already had a few volunteers in the chat, and I think first was Lars, right? Feel free to come on up. Okay. And yeah, we'll just kind of go ahead and talk about your project and what you're working on. We'll try to keep it around the 5-minute mark and have people be able to then answer questions afterwards, if that's okay. Good. This microphone?
Hi, I'm Lars. A few years ago, I talked with then co-workers about what they like and dislike about CI. And by CI, I mean continuous integration, not continuous irritation. They all want CI because they see the benefits. None of them wanted to use CI. And one of the primary problems was debugging is hard, or you have to wait for CI to actually run. At that job, the longest queue I saw was 2 days. That was not fun. I started thinking, and a couple of years ago, I started doing something. The idea I have is that companies decide I like open source. Open source developers also have these problems. So how about we all share the extra capacity we have? I have too many ThinkPad laptops at home. I could run CI for other people. But then the problem is I don't trust other people. I'm not running their code on my computer without protection. So I wrote and I'm still writing a CI engine called Ambient that runs things in so well isolated that I can sleep at night. And then the idea was that the name Ambient comes from the idea that it's always there, like it surrounds us. CI is watching us everywhere. But then to actually implement the server side of all the watching is not a thing I'm actually interested in, so therefore Radical was invented. Lorenz will correct me tomorrow. But basically, I have married Ambient and Radical such that any Radical node can run CI, and it doesn't even have to be Ambient, but I like Ambient, such that we can have any number of nodes that run CI in a safe and secure manner without having to lose sleep. And everyone whose CI, for whose project CI is being run gets to trust themselves. They decide whose CI they trust. So I might run a malicious CI for, say, Joey, but if Joey is stupid enough to trust me, he will suffer. I wouldn't actually do that because I like Joey. I will be malicious to other people. That's a joke. But that's what I have, and the basics are working with Radical and Ambient. There's about 2 billion different details to fix, but that's software development. That's all. Thank you.
Thank you very much. Does anyone want to ask any questions or have any comments directly on what Lars just talked about? Yep, back.
Sounds really interesting. I'm wondering, how do you deal with build logs and build artifacts?
Well, it's a little complicated, but the CI node that stores them, that runs the CI, so the Radical node that runs CI stores the logs and artifacts. That's very basic and incomplete, but I've only been working for this for a few years. I'd like help. Thank you.
Good. Thank you. All right. Any final questions? Nope. Okay, then I think our next volunteer was Alex. Come on up. Round of applause.
Thanks. All right, so I am not presenting my project, but rather somebody else's who is sick and not here today. So I haven't built any of this, but hopefully I can explain it and answer some questions. So we don't really have a project title yet, but I'm inspired by Neurobagel, so we're going with Kürbiskernbrötchen for now. And the idea is just, network brings reproducibility problems. The simplest way is, let's say you're trying to build a container and you're trying to do it reproducibly. And let's say you don't have Debian snapshots, because that just solves problems, and I'm trying to keep in a problem space. And if you do an apt update, then you're going to get a different answer depending on your day. And so how can we make that something that's reproducible? So the idea is intercept that and save the network responses into a data set, and then allow the same thing to be run over again. If we already have that asset, then we intercept again when you replay it, and then we can give you the same answer. Not sure if that's terribly clear, but yeah, that's pretty much it.
Thank you. Does someone have a question? Yeah?
Not really a question, but I just want to ask you, look into NICs.
Yeah.
Really, it sounds like it already solved that problem.
Can it, yeah, so I haven't looked, so I've heard about NICs, and I haven't looked in, I've looked into a bit, but I haven't gotten deep into it. But I think for us, the problem we're trying to solve, and what I'd be interested if NICs can solve it, is like generic person is trying to run, like from a scientist standpoint, like they have a container and they've written something, which it might as well just be a black box to me. And that's being shipped somewhere to, say, a clinical network that cannot have network access. Like, can NICs help me in a scenario where I don't need this researcher to learn an entire solution to the entire problem space? Because that's basically what I'm trying to do, is just shim pretty much the ugliest kludge possible that opens up options.
So I guess there has been work that basically puts end users into a position where they do not have to know about NICs.
Okay.
But I haven't looked into that solutions because I know NICs. Yeah, but you really want to research how NICs does stuff, and that might solve a lot of your problems you're trying to accomplish.
That would be fantastic. Thank you. And there seem to be...
Yeah, a couple more questions, right?
Yeah, just continuing on exactly on that topic. So I think you have to differentiate between building software and distributing it, because container images are basically just a distribution format. Yep. It's like one bundled thing. And NICs, or I prefer geeks at this point, but same model, is focused on building software. And with sufficiently advanced build system like NICs or geeks, you can just package it up as a container. So NICs has like a Docker build layer Docker image, and then you can package whatever software is available in NICs packages into a Docker image and ship that. And then the receiving party doesn't have to care about NICs at all. Same for Geeks. Geeks has Geeks Pack, which can build Docker images, or what does it do? App images, or I think self-extracting just archives. Okay. And yeah, I agree. Look into it. Okay, it's great.
Thank you. And yeah. Sounds like really good solutions for the use case that I mentioned, which was reproducibly building a container. So.
Yeah, so I looked a lot into the Debian reproducibility use case with Philip together. And so there is a snapshot server for Debian. You can just use the old archives. You could also don't do Debian updates. And there is also the Debian DVD distribution. And besides the normal OCI containers, there's also a great project called MKOSE, which you can use to build read-only Debian images. And there is also kind of they have this mode where you first get the sources, and then you can also kind of store the cache of the packages you had. This MKOSI is really, really great. It's kind of all of the systemd world. And yeah, so there are multiple solutions. We can discuss about this.
Yeah.
If you're particularly interested about Debian, I thought about this a lot.
I'm very interested in Debian. In general, I use it all the time. Yeah, and I definitely can tell that. So my example definitely kind of led with my chin here, and there's a lot of solutions to the container space. We were also just trying to allow arbitrary code, like trying to approach it less from just the reproducible container standpoint and more that we have a black box and it's making arbitrary network calls, and can we remove that as entropy basically, and can we just replay that? So it's definitely not the right solution to, like you guys are talking about the good proper solution, and those are definitely the way that one should go when you possibly can. And this is just more of the, we're trying to, like, don't let perfect be the enemy of good. Like, can we make this better in places that we don't necessarily have a reach into quite yet? So that's kind of the motivation in that space. You had one more, and then I'll get out of the way because it's supposed to be lightning.
It's me again. You can build Docker images, OCI images with Nix, but you can also use Nix to run VMs where you execute your build in. We do that at work. We start a Debian VM because we have to do Debian packages. And we do not have to have Nix artifacts within that build, so we start the VM in Nix, or with Nix rather, and install the tool chain in there to build a package that does not know about Nix. Just so you know, it's maybe it will come up at some point if you do your research.
Me, a whiteboard, and beer. Okay.
Sorry.
All right, thank you.
Okay, thank you very much. I think our next volunteer was Lorenz, is that right? Is that what I said? Yeah, come on up. Would you like to? Yes, of course, go for it.
Because no one was doing that before. Okay, so this is a really impromptu idea. I'm not affiliated with this project, I'm just using it, and I think it's so great that I want to spend these 5 minutes to show it to you. Okay, so this thing on the left side might look a bit like the output of git log to you. Surprise, it is the output of git log. But we are viewing this not through Git, we're viewing this through something called Jujitsu. Jujitsu is a new kind of approach to version control. It's not fundamentally new, but it has like a new UX layer on top of what we already know. The whole storage layer is Git, so it's fully Git compatible. You can Git push, Git pull, and so on. But what this really does is when you're working on something and reordering commits, rewording commits, rebasing commits, merging and stuff like this, resolving conflicts, that's what this tool is for, okay? So it's fully compatible with any Git forge you already know and use. But it really makes all of these flows, juggling your commits locally and splitting them up into smaller pieces locally, making all of this easier. And I want to do a bit of a live demo, so this will obviously not work, but I'm still going to try it out. One thing that is different to Git is that you don't just get the commit hash that you're used to, but you also get another identifier for every change. And this is written to the commit itself. So if you look at a commit in Git, a commit object, then as usual you have a tree and a parent and an author and a committer and blah, blah, blah. But if you use JJ, you get an additional header in your commit, which is the change ID. And as you know, when you rebase stuff, the commit hash changes all the time, and referring to commits gets a bit tedious if you use stuff like git rebase auto squash, where you have these things like exclamation mark fix up and so on, and then it uses the message to refer to stuff and so on. If you know that, then you know that referring to commits as they change is hard. JJ took a very simple approach here and just generates a random ID and puts that in the commit, and it just stays there. So if you rebase the commit, if you move it around, this identifier will stick with it. And this sounds very simple, but it solves this problem of when you rebase that the hashes change, and then you get confused where things went. On the right here is just my shell. On the left, I use a small TUI wrapper called JJUI above JJ. And now we can do cool things here. So if I press N, I get like a new commit on top. If I press N again, I get a new commit on top, and so on. If I press D, I can write a message like hello distribits. I'm a bit nervous, so I will mistype. And then you can see if I go to an earlier commit here and I press N again, I get a commit on top of what I have selected. So this easily enables you to like branch and handle your branches, and it also enables you to rebase really quickly. You can select multiple commits at once and you can abort them. You can, for example, if you have things that are related and you want to look at them together, you can select multiple commits here. I will select these 3 and then press new. You get a new commit that is on top of the 3 commits I have mentioned previously. So now we have a merge commit generated. This merge commit has 3 parents. We can always undo. So if I press O, I can see an operation log. So every operation I just did, this new empty commit, and so on, I can always restore that state. So I can basically time travel without all of the complicated Git commands. I can do that right in here. And I can also do things like absorption. Maybe I can demo this really quickly. So here I have a commit, and this is just a preview. And you can see that I changed this line where it says something like git2 default whatever. And I want to change this, so I just press N here, which gives me a new change on top of what I have just changed, what I have just selected. Then I can go to this line. Oh, no, sorry, I'm on the wrong commit currently. I wanted to do this on the merge. So what was my mistake now? I went here and pressed N, but that's not the cool feature I want to demo. I'm actually on top of a merge commit. So you can see the commit with like the change with change ID OZR here has like, 5 parents. And I have a new change on top, which is currently empty. I go and edit this line, which said something about git2. Save that. Now I have here this new commit where you can see the diff. And what I can do now is I can tell JJ to absorb these changes into previous changes, and this goes across merges. So if I press A, you see that here it now says affected by last operation, and my commit at the very top is empty. So what happened? The change from the very top commit moved back to the last commit that could uniquely be identified to have changed the same line, okay? So I can undo this. Here's the diff of adding gigs. If I look at this line here, you see it's just adding git2. And if I do the absorption again, Shift A, now you can see the change was absorbed into this commit. So we have here not only git2, but gigs as well. So what does this enable you? You can work on multiple different kinds of like flows of patches, of changes in parallel. So you can see here I'm working on 4 things in parallel, but I actually don't pick a particular branch to work on. I work on the merge of all of these changes, and then I can see how all of my changes will come together in the main branch once they will be merged. On top of that is where I work, and when I make a change and I'm done with that, I then can usually have this absorption feature which will automatically apply that to like the correct history that is behind the merge. Other things that you can do, and just kick me off the stage as soon as this gets boring, but You can, for example, I can move the master bookmark here. So you might see that the color indicator here for this commit is a bit like it's bluish. Bluish means I have pushed this somewhere, so it's considered immutable, because, you know, if I change this, then my coworkers, my colleagues would see a change in hash and they would be confused. And I have moved the master to here. And now I have, for example, this merge commit here. It has a, just think of this as like a branch name. JJ calls it bookmarks, but it's called gigs. And it has many parents, right? So these are like these 4 different patches that I'm working on. And master has advanced. So I have just created this new empty commit here, and I moved the master bookmark, as you can see here. I moved this there. And now I need to rebase my work, right? So we're just assuming that someone else has moved the master for me now, but I want to rebase all of my 4 gigs patches on top of that now. So what do? I need to modify this slightly because I need to use the local master. And now, as you can see, I have just rebased these 4 feature branches all at the same time on top of master. And now you will be thinking like, oh, but what if there are conflicts, right? Because in Git, if you do these things, then you get conflicts. And in JJ, the conflicts are like first-class objects. So I actually have in my history conflicted commits, right? So these ones that are marked red, they contain conflicts. I did not yet resolve these conflicts. And this is another change in like the UX. If you rebase in JJ, it will not stop as soon as there is a conflict and ask you to resolve it, but it will just accumulate these conflicts and tell you later on, look, there's something you should probably resolve. And then you can go in and actually resolve that. Yeah, so this was just like I don't know, I'm running out of ideas at this point. If you have any questions, feel free to ask, but this is just like a very speedrun view of JJ and what it can do. Thanks.
Thank you very much. We have a question here. Okay.
You said it works with any forge. How does it work when you collaborate with someone who's using normal Git and then someone who uses JJ on the same repository branches, pull requests?
If you just run a Git pull in your repository, you will just get a new reference. So for example, I don't know, like this thing here, like this is a branch name. It looks a bit weird, but it is. And you just get another branch in your graph here, and then you can work on it as usual. So I don't know, it probably doesn't really answer your question, but you just get a branch and you can work on it as you want. You can do something that's called co-locating. So the repository itself is a Git repository. So you can use JJ and Git in parallel, and you can just run Git separately as you're learning how to do something in JJ maybe. You know how to do it in Git, but you don't know how to do it in JJ, then just do it in Git, and JJ will catch up. And yeah, so it works on top. The only difference is that it generates these headers, but most of the forges don't really care about these.
Okay.
Yeah, maybe you have to be a bit careful of like changing history, because everything you do, or not everything you do in JJ, but in JJ is really easy to change the history, which with Git sometimes is a bit of a, like you have to think about. But it protects you with these immutable commits. So the default selection for immutable commits is quite reasonable. It looks at what was pushed to your main branch, and then if I would now press to change the message here, it tells me this is an immutable commit. You should probably not edit this. And if I'm on the shell, I would have to do something like, okay, let me please edit something that you marked as immutable. And you can configure you can configure the, yeah, this is a bit of a bad example, but you can configure what they call revision sets, and the immutable commits are just a revision set. So you can define your revision set for immutable commits, and these revision sets allow you to say something like if it was pushed there, or if it's part of this branch, and so on.
Very good. Thank you very much.
Sure.
I believe yeah, great. Our next volunteer was Andreas, I believe. You still want to come up? Yep, come on up. And with laptop. Good. Okay.
Yeah, also with short demo.
Alrighty.
Where are we? And I'd like to showcase a little thing that we did as kind of a data set inventory. So if you have many data sets in your data repository and you want to keep the overview, I'd like to tell you this story like backwards. So this is the end result, what you get. This is a nice search and overview page for all your data sets. And now you can search the metadata. This is basically the F in the FAIR principle. And here you can say, there's so many metadata fields. Is there something which has country in it? Oh yeah, there's something. Show me. And then you need to scroll a little bit, and then here it is. And you could also say, let's group by this. Where is it? There's it. And then it groups it for you, and then you see it a little bit nicer. And you can select what metadata you see as a column, so you don't need to scroll horizontally for kilometers all the time. And then one thing, actually the primary key that I always use is the URL to our GitLab. And if you click it, it will open in the correct branch, into the correct subdirectory, and so on. And then here you see like an overview page of your data set with multiple files. I prepared a nice README with the preview picture and everything, and then it's a little bit nicer. And so you said, I found the most interesting data set. Let me click on it. Let me look at it. And now one step back, how do we do it? This dataset.json file, this is like our convention. You can name this whatever you like, but I always tell my users and colleagues, create a dataset.json file with all the metadata in it. And then it looks like a JSON file. I can make it a little bit larger, but the specifics are just not interesting. I help them with extracting their metadata into something like this. And of course, if you get your metadata some kind of automatically, it's easy to put it in some kind of JSON. And then, like all those dataset.json files I put I get together, I see, are they similar enough? I make a JSON schema out of it. And this is how I create this table, basically. And then, whenever you have a new data set that you add, or someone else, some of your students adds it to the branch or something like this, then they say git, either they say git push, or of course data-led push, or something like this, and then it goes to the GitLab or whatever. And in this case, with GitLab, of course, there is a nice thing called webhooks that you can use. And in the background, we just use a webhook which calls a small Python service of ours, which says, there's a new commit or new push with multiple commits. Let's have a look. Are there some files that changed or new, which are called dataset.json, or whatever you want to call them? And then it says, there is something which changed. Well, let's have a look at it. And if it finds it, then it will parse it or just read it in and add it to the database again. So then if you put refresh here, you would see what your group contributed in the meantime. And then of course you can say, show me only the master branch, or show me all the branches, or whatever. And this is a nice way of keeping the overview if a group, also remote people, like contributing to big data collections, And of course, you can work with branches and everything, but like one place to search for, do we have complete simulations with these fruit flies who have red eyes and are left-handed and are born on an even Tuesday in March, or you know, whatever you like. And yeah, this is kind of the solution. If you don't have something specific to your community, like I know many chemists and yeah, many fields have like huge data portals which have visualization put in and specific metadata schema and whatever. If you have something like this, you use it, of course. But if you don't have something like this, I think this is nice to break this chicken and egg problem, because if you don't have your metadata schema already, how do you know how to produce it and so on? So yeah, I don't know, the poor man's version, or just the starting point. And yeah, if you find this useful, I would be happy about feedback or how else to use it, sorry, or to extend it. And I think this is my short demo now. Thank you.
Any quick comments or questions? Here. Okay.
Hi. Yeah, thanks. Very interesting. You mentioned that you generate the schema out of the JSON files.
Yep.
Do you know RO crate?
Pardon?
RO crate, research object crate. This
Nope,
is
no.
a similar approach, but it puts not a JSON file on top of everything, but a JSON LD file. So you can also include links of your directory structure and so on. Might be worth looking.
Maybe I'll ask you later for the UL for this one, but this would certainly be interesting.
Okay, thanks, yeah. For me too, so we should chat. Thanks.
Is there a public instance where we could kind of play with this?
Actually, I can invite you to our instance, and this is already my tutorial case, and I want to make it public eventually, not yet, though.
Okay.
Okay. Great. Thank you very much.
Thanks a lot.
Next volunteer is Michael.
Okay, there are many ways in which you can, or with which you can install Git Annex. I'll do it like this. Tool, install Git Annex. Oh wait, before I do it, there's no Git Annex. UV tool, install Git Annex. Git Annex. Also recent. UV. Anybody not using UV if you are anywhere close to the Python ecosystem? No. Yeah? 1, 2. Okay. Maybe that changes now. So UV is really cool. What I did with this one command is there was some environment being created and Git Annex was placed into it, and then things were set up for me so that I can forget about all of this and just use Git Annex. This is awesome for if you want to get people to use Datalet, because Datalet is written in Python, and usually for many, many years the story was, well, if you want to use Datalet, then first you install Python, and then you install Git, and then you, the Git Annex. This works different, right? So, and it depends on the platform, and then you install Datalet, and then all the extensions that you need, and so it's a very complicated thing. Now, Git Annex is a Python package for all things that matter, right? Local versioned environments, dependencies of other Python packages. I think this is really cool. So UV, if you don't know it, check it out. This tool thing is magic. It just puts things in the path as if you would install a system package. And I found this really cool, and then I looked, how can I get UV, right? Because that's the alternative to install this, install that, and it turns out you can get UV in 1,000 different ways, and they're all very simple, including from PyPy. And UV is written in Rust, and that didn't compute for me. So I looked for the first time at, what they put there on PyPy. And you can see they have builds for all kinds of stuff. Architectures, systems, like lots of stuff. And I wondered, how did they do that, right? And I come from a Debian context where you hand in the sources and somebody does the binaries, right? But that's not the way the PyPy works. As long as you give them something that meets some requirements, and in particular size requirements, they'll take pretty much anything. So I built a Git-Annex wheel. Wheel is the Python packaging format, and there's a little bit to it, but not much. So this is the Git-Annex wheel. It sits on GitHub for one reason. They provide all the builders for all the platforms. So that UV tool install Git-Annex works on my Debian machine, but it also works on any Mac and on Windows. And there's even a wheel for if you happen to be stuck on CentOS 7 for whatever reason, you could still use that command, which is, I think it's pretty cool. And so the thing that it does is basically it takes the Git-Annex build instructions from the Git-Annex website, copies them into a Git action specification for every platform, and then it lets the GitHub system run things, and out comes basically a direct submission to PyPy with Git-Annex, right? And it has builds for Windows, Mac, and Linux at this point. And the only thing, so this is the whole setup. So in case you're wondering what does it take to maintain this, when Joey tags a release, then the Git-Annex repository hangs off of this one as a submodule. So I forward the tag, commit it, and change this version. Because sometimes things need to be fixed. So that's not a one-to-one equivalent. So that's basically the Git-Annex, the Git-Annex version. And then things get pushed to GitHub, and the rest is automatic. And that makes it possible. Right now, Git-Annex is about 20 megabytes of a binary to download. And you've seen that with UV, it does all kinds of fancy caching inside. So it takes, it's really fast to do this. So that's it.
Thank you. Anyone have a question? Yeah.
Yeah, so we also started to use UV in our team, and it kind of sped up the whole development processes. But like what I kind of think, it kind of gives the same development workflow you usually see in JavaScript development with NPM, which has also its downsides, which I did not see that much in the UV Python world. So I wonder why that is. Or maybe there is some kind of trap we go into when we are starting using this sort of workflow. This just was what I was kind of wondering about this tool. Yes.
Yeah, I've literally no experience with the JavaScript world. I'll try to make
it's a mess.
Keep the distance. But what I was talking about is not development workflows, right? It's more like deployment of specific things, and just get people in the position to actually use the tool. And this is more the focus. JB?
There's no quirk with a conda environment with UV. You can install UV, use UV in the conda environment with no problem.
Probably.
Okay.
Well, I think the cool thing is that you need not have anything to start, and it's like install UV and then whatever you want.